All right, these are the Chapter 6, Notes 9. We're going to look at probabilities of independent events. And today we're going to talk about a weather website that gives a 5-day weather forecast, which lists the predicted high temperature, a description of the cloud cover for the day, and the chance for precipitation. You're going to notice that the chance of precipitation each day is 10%. We're going to assume in this case that there's independence for precipitation, which is maybe not necessarily true, but we're going to assume it in this case. The likelihood of precipitation one day is not going to impact its likelihood of precipitation for another day. So we're going to calculate some probabilities regarding the likelihood of rain over the 5-day period. And we're going to start with the first question, which is what's the probability that there is precipitation all 5 days? Usually what I like to do in a problem like this is I like to kind of start with what does the statement say kind of in math speak. And in this problem, what we're going to say is that we're talking about the probability of all 5 days. Now, if you want to kind of take it a little bit further, what you could say is this is the probability that it's going to rain and rain and rain and rain and rain. So now we're kind of using the intersect or and tool that we've brought up a lot this unit. Now, what we've learned about this unit is that whenever you have these independent events, and means multiply. So the probability of A and B usually equals the probability of A times the probability of B if A and B are independent. So what if you have 5 consecutive ands? Well, it does mean that we're going to have 5 consecutive multiplications. The probability of rain all 5 days can be found by multiplying probabilities of, well, rain for all 5 days. The probability of rain times itself 5 times. When you actually calculate this out, you're going to end up taking the probability of rain, which is 0.10, times itself 5 times. Now, if you're using a graphing calculator, a lot of times the answer they'll publish is 1e negative 5. I don't want you writing the answer like that. Now, if you have a regular scientific calculator, usually the scientific calculators handle a little bit better. 0.1 to the 5th power is equal to 0.00001. So that's better form for your answer. Another thing that you might also want to consider is just writing the answer as 1 times 10 to the negative 5th power. The e function, you want to avoid this on the AP exam because that's using kind of calculator language, and the graders prefer something that looks a little bit more normal, like 1 times 10 to the negative 5th. Now let's look at this other question. What's the probability that there was precipitation on none of the 5 days? This is obviously more likely because there's such a slim chance of precipitation. So kind of talking about probability speak, we're looking for the probability that none of the 5 days would get rain. In other words, this is the probability that there's no rain and no rain and no rain and no rain and no rain 5 times. Again, we have independence, so we can multiply the probability of no rain by itself 5 times. Another thing you may want to consider is using the complement tool, because no rain is like rain complement. So we will be multiplying the probability of no rain 5 times. And the probability of no rain is 90%. We're going to multiply that by itself 5 times. When you crunch out 0.9 to the 5th power, the answer that you get is 0.59049. And that's how you solve something like this problem. Now, I want to do a couple follow-up questions. First of all, for our first question, when we were asked what's the probability there is precipitation all 5 days, let's think about what's the complement of there is precipitation all 5 days in words. Complement means not. So we're going to throw a not in this sentence and say, well, there is not precipitation all 5 days. That's kind of clunky. So maybe another way of saying it that might sound a little more logical is there is at least one day it does not rain. So if there's not precipitation all 5 days, that means there's at least one day where it does not rain. What's the probability of this event? To find a complement, it's 1 minus the probability it does happen. So the probability there's precipitation all 5 days is 0.00001. The complement, there is not precipitation all 5 days, or there's at least one day it does rain, is 1 minus this. So to find the probability that an event does not occur, take 1 minus the probability that it does occur, and you get 0.99999. Similarly on the other side, what's the complement of there's precipitation on none of the 5 days? Well, this is just kind of bad English. You would say there is not precipitation on none of the 5 days. That's really clunky. What's maybe another way of saying that? Well, Another way of saying that statement is there's at least one day that it does rain. I think that makes a lot more sense. So the complement of there's precipitation on none of the 5 days is there's at least one day that it does rain. And to find the probability of this event, again, it's 1 minus the probability that there's precipitation on none of the days. So we're going to take 1 minus this 0.5909 number, and what you end up with is 0.40951. Moving along, I'd like to take a look at two problems on the next side here. On all the problems on the back side, we're going to assume independence between events. We're going to look at first scenario, where we're going to let A getting a question right on a test, and the probability of A is 90%. In scenario 2, we're going to let S represent the situation MSU wins, and M be the situation that U of M wins. And we have a probability that MSU wins of being 0.80 and probability of Michigan winning 0.75. What I'd like you to do is I'd like you to try to answer the questions on 1 and 2. See if you can show some work. I'm going to ask you to pause the video, see if you can solve these problems correctly, and then we'll come back and check your answer in just a moment. All right, so for question 1A, we're looking at the probability of getting all 5 questions right. This is the probability that you get the first question right, and the second, and the third, and the fourth, and the fifth. Because we have independence, you're allowed to multiply the probability of getting the question right 5 times, so you can write that as 0.9 to the 5th power, and when you crunch that value out, you get 0.59049. Now, getting no questions right, that means you're getting the first question wrong, and the second wrong, and the third, and the fourth, and the fifth wrong. Now, we can write wrong as being right complement, not right. So we have not right, and not right, and not right, and not right, not right, right, not right. The probability of not getting the question right is obviously 10%. So we're going to take 10% to the 5th power, and when you crunch that out, you get 0.00001. On part C, if you get all 5 questions right or all 5 questions wrong, all 5 questions right we've already calculated. That's that 0.59049 number. We've also calculated the probability of getting all 4 questions wrong or all 5 questions wrong. That's 0.00001. Or means add. So what we're going to be doing here is we're going to be adding these 2 probabilities that we just came up with. And when you do that, the total that you get is 0.5905. Now, we're not going to subtract off anything. Sometimes we do with OR problems, but it's impossible to get all 5 questions right and all 5 questions wrong at the same time. Now, how do you find the probability of getting at least 1 question right? Well, for this, you have to kind of think about this. One of 2 options is apparently possible. Either you get all the questions wrong, which we've already calculated that probability, or you get at least 1 right. These events are complements of each other, so to find the probability you get at least 1 right, subtract 1 from the probability of getting all questions wrong. Either you get all the questions wrong, or you get at least 1 right. So those are kind of your 2 options. And to find the probability, you take 1 minus 0.00001, and you get 0.9999. 9. For letter E, the probability of getting at least 1 question wrong. Again, kind of a similar scenario. Either you're going to be getting all questions right, and we already know what that probability is, 0.59049, or you get at least 1 wrong. These are complements of each other. So to find the probability you get at least 1 wrong, take the probability you get all the questions right and subtract it from 1. Anytime you have this at least scenario, at least 1 right or at least 1 wrong, figure out what the complementary event is. You either get at least 1 wrong or you get them all right, and you can subtract this probability from 1 and get your solution. In problem 2, find the probability both teams win. We've talked a lot in class about the idea that whenever you see both is usually an indication that you have and. Both teams winning means MSU wins and U of M wins. And we said when you have independent events, and means multiply. To get your answer, you take the probability MSU wins times the probability U of M wins, and you get 0.60. Now, both teams losing. Both teams losing is basically the idea of both teams not winning. So MSU does not win and U of M does not win. College football, we don't have ties, so we're going to assume either you win or you lose. So the probability MSU does not win is the complement of them winning. So it's going to be 1 minus 80% or 20%. The probability of U of M not winning is 1 minus 75%, which is 25%. We multiply because it's an AND problem, and the solution you get should be 0.05. To find the probability at least one team wins, what we can do to find this probability is at least one team winning means we're looking at the probability that MSU wins or U of M wins. Now it's possible they both win. Remember, or does mean that possibility that both teams could win. Because it's an OR problem, we can set up our probability for OR events, which is found by taking the probability of A plus the probability of B minus the probability of A and B. And in this scenario, it's possible for both MSU and U of M to win. So we need to kind of subtract off that probability. We know the probability of MSU winning is 80%. The probability of U of M winning is 75%. We also have already calculated the probability of MSU and U of M winning, which was 60%. And when we subtract that off, we get 0.95. Again, as we look at problems 3 and 4, take a moment to pause the video. Let's assume in problem 3 with the rock, paper, scissors example that the probability of actually winning is 1/3. So using that probability, see if you can answer parts A, B, and C on 3 and the bug zapper question on problem 4. Again, pause the video. We'll come back and check your answers in just a moment. So we're playing 3 games of rock, paper, scissors, and we're looking for the probability that you win all 3 games. Now the probability of winning 3 games means that you win game 1 and you win the second game and you win the third game. Now we know that and means multiply, so what we're doing here is multiplying the probability of winning 1/3 times itself 3 times. That's 1/3 to the third power. You could write it as a fraction like 1/27, or if you want to write it as a decimal value, you can do that, which is 0.037. How do you find the probability of winning at least one game? Well, one option you could do is find the probability of winning the first game or the second game or the third game. To be honest, a triple OR problem is a little bit difficult to work with. So let's kind of consider this alternative approach where think about what does it mean to win at least one game? Well, either you win at least one game or you don't win any of the games. Now it's easy to find the probability of not winning any games. That would be 2/3. The complement of winning, which is not winning 2/3 of the time, to the third power is 0.296. So if you don't win any games, that's the probability. Winning at least one game is the complement of this event. Either you don't win any games or you win at least one. So we're going to take this 0.296 and subtract it from 1, and you get 0.704. Part C, what's the probability you win none of the 3 games? We just calculated. It's 2/3 times 2/3 times 2/3, which is 0.296. Our final problem involves a bug zapper, which has a pretty high success rate at killing a fly. Now, if 20 flies approach the bug zapper in a day, to find the probability that the bug zapper zaps all 20 flies, what you need to do is find the probability that it zaps the first one and the second and the third all the way up to the 20th. This means we're essentially taking this probability of success, 0.98, and multiplying it by itself 20 times. When you do that, you get the decimal 0.6676. What's the probability that it fails at least once? What does that mean? Well, think of it this way. Either the bug zapper zaps all 20 flies, which we've already found the probability for, or it fails at least once. We found the probability of zapping all 20 flies is 0.6676, so obviously the probability it fails at least once is 1 minus that, because those are kind of the 2 options. Either the bug zapper worked every single time or it failed at least once. So we subtract 1 minus 0.6676 and you get 0.3324. This gives you some more experience with working with probabilities of independent events.